Hey class, these are the notes that go along with sheet number 4 for synthesis reactions. I'm going to put some steps up here for writing products for synthesis reactions. The steps are actually pretty simple. You've seen them before. It all kind of works the same way. When I have a metal and a non-metal, just like I do here for my example with sodium plus chlorine, okay, I'm going to first, on the right-hand side, this is only for the products I do this, I write the symbols and charges, just like we did before. And then, once I do that, symbols and charges, Na with a plus, Cl with a minus, I crisscross. And then, when I crisscross, I get rid of the plus and the minus, because the plus 1 and minus 1 crisscross to give us ones and ones, which we don't write. And then the last step is to balance. Notice I have a 2 here, so I need a 2 in front of the whole compound to give me 2 NAs and 2 CLs, so now my CLs are balanced. And then I need a 2 in front of the Na, very simple to balance. And that gives me a 2-1-2 reaction. Super easy. So on the right-hand side is symbols and charges, step 1. Step 2 is crisscross. Step 3 is balance. Now what happens if I have a transition metal? Fe is a transition metal. And if you check the periodic table, of ions, you will see that iron is in a cell that looks like this. It says Fe with a plus 3, and then it has the name iron 3, and then there's a dotted line, and it has Fe with a plus 2. We're going to pick the top one because the top means it's more common. So that means I'm going to start off with Fe as a plus 3 like that, and S. What is S? S is sulfur, and it's right below oxygen, which means that it has the same charge as oxygen, and oxygen always has a minus 2. So S is a minus 2. Here I have my symbols and charges for the right-hand side. Now I crisscross. The crisscross looks like this. The 2 and the 3 come down, and then I can get rid of the charges here, like that. So Fe2S3 is my compound. And then my third step is to balance. Balancing is so easy for this one because I just put a 2 in front of the iron, Fe, and I put a 3 in front of the sulfur. And that's it. Now everything's balanced. Now let's do a couple examples so I can show you what's going on, because there is a little bit more confusing part. That is part number 2. So let's take one quick look at part 1, where we have the symbols already given to us on the left-hand side. So letter A is exactly like one of the other ones. So I'm gonna skip letter A and go right to letter B. Letter B for symbols and charges looks like this. Step 1 is to write the symbols and charges. Mg with a plus 2. Oxygen with a minus 2. Now they equal 0 when we add them together, so we don't have to crisscross these, thank goodness, but I do have to balance the equation because of the 2 here, and there's only a 1 there. So I put a 2 in front of the whole compound, so it's 2MgO, which means I need then a 2 in front of that Mg. And now I have 2 Mg's and 2 O's on both sides. Well, that was pretty easy. All right, I'm going to let you work on some of those. Let's take a look at the second part. Now the second part is a little bit more difficult because we have to worry about Brinkelhoff on the left-hand side. So Brinkelhoff, as you know, is when I have any of these 7 elements by themselves. Sodium is not Brinkelhoff, so I can just write sodium by itself. Okay, there's no symbols and charges here. There's no charge for sodium when it's by itself. How do you know sodium's by itself? When the word is written and then you see the plus sign and then you see another element, the plus sign means that these elements are separate, not together. Okay, so that's how you know to write sodium down here without any charges. And that's how you know to write bromine down here, and you can include the 2 for bromine for Brinkelhoff because it's not bonded to anything, because the plus sign here keeps it separate from sodium. Okay, that's important to know. So let's take a look now. We can do the same thing that we did before. Now on the right hand side I can write down the symbols and charges. Sodium is a +1. Again, I'm getting this from the periodic table of ions. Bromine is underneath fluorine, and fluorine's a -1, so it has the same charge. So a +1 and a -1, which means that we don't need to crisscross this because it equals 0 already. But bromine does have a 2 from Brinkelhoff, which means I need a 2 over here. And then that does mean that I need a 2 in front of the Na. So my balance equation is 2Na plus Br2 yields 2NaBr. Let's see. Let's do one with a little bit more substance. How about letter D with aluminum? And again, on the left-hand side, I'm just writing the symbol down, no charges. And if I have Brinkelhoff, which I do for chlorine, then I need to put the 2 down. You must have the 2 for Brinkelhoff. All of these that look like this are Brinkelhoff. Okay? You should be writing Brinkelhoff for all of these elements that are included in Brinkelhoff. On the right-hand side is where I write down Al with a +3 because aluminum has a +3 charge. Cl is in the same group as fluorine, so it has a -1 charge. I do my crisscross, so I get AlCl3 and get rid of the charges. Here I have a little problem because I have a 2 for chlorine on the left-hand side, and I have a 3 for chlorine on the right-hand side. If I multiply chlorine on the right-hand side with a 2, 2 times 3 gives us 6 total chlorines. And then what would I do on the left-hand side to get 6 total chlorines? I would use a 3, like that. 3 times 2 is 6 total chlorines. Now I have 6 on both sides. I do have a 2 in front of aluminum here, so I do have to put a 2 like that. So 2, 3, 2 is this reaction. All right, I'd like you to continue on and give it a try. Finish this up and submit this. You do not have to submit the notes that I wrote down earlier, but you do have to submit sheet number 4. Please ask if you have questions.